Hello everyone, welcome to my channel. My name is Meena. What we do is, or in my channel, I try to cover some concepts. We take one concept and try to explain it in detail. Today, what we are going to do is know a little bit more about gRPC. What is gRPC? Now, it's in a nutshell, what gRPC does is allows you to talk to, or it allows client and server to talk to each other. It's a communication framework. Ever since we started developing code, writing programs, we started distributing code into different machines. So earlier back in the days, the entire program was available to download on a piece of floppy. It was just a small code, right? Where both the client server, all the functionality, most of it could fit on a floppy disk. Then came the CDs, okay, compact disks. And then the distributed architectures started gaining more popularity as the code base started growing more and more. We started keeping the client code on a different machine and storing the server code on a different machine. So basically what we started, and then these were two physical machines. Most of the company had localized data centers. And then we started moving code into the cloud where it's accessible across continents. Now, but when the code is distributed widely across, we need some mechanism for the different pieces of software that are deployed at different servers to talk to each other, for which we have different technologies available currently. Back in the days, it was remote procedure call. Then we have REST APIs. Nowadays, we have REST APIs, which is extremely popular because of its simplicity. We have GraphQL. We have WebSockets. We have microservices available, and which uses gRPC. So your system can talk to any other microservice which is deployed somewhere in the cloud using gRPC. Today, we are not going to learn about REST. We are going to talk about gRPC. So gRPC, again, see, RPC, it's a remote procedure call, which means a client is calling or invoking a method on a server, which is the server code is running in some other machine somewhere else, but the invocation is such as if both the server and the client are running on the same machine. It is language agnostic, super fast in performance. Okay, the performance is really good. We'll see why it is so good. Okay, it is open source. It is language agnostics, which means you do not have to depend upon a certain language. You can have client uh, written in some language, server written in some other language. Okay. So there are two key technologies which helps the gRPC function so fast, or gives gRPC the higher edge or advantage over traditional REST APIs. One is what is the use of the protocol buffers. And the second is HTTP2 protocol that gRPC uses. Okay, REST uses HTTP1. What are protocol buffers? For those who are familiar with GraphQL, okay, protocol buffers are basically simple text files where you define all your APIs and the parameters that each API invocation will have or pass to the server. Okay, so it forces an application development to be API first method of development. Like before you can code your server, before you can code your client, you first have to define what APIs is your client and server going to provide. Or first of all, what API your client will need, and then based on that, need, you write the server code to implement or provide that functionality. So you have the technology of API first. We will see in the end, at the end of the lecture, we would also see a simple working example of Hello World using gRPC. So stick around till the end. So what happens is, even though you write the .proto file in a simple text language, you have to compile that, and it converts to a binary form. It is serialized into a binary form. And then gRPC uses HTTP2 protocol, the transport protocol, so which allows true multi-streaming. Okay, so you can stream between both the client and the server at the same time. Okay, here REST, you can only stream from the server to the client, but here HTTP2 protocol allows two-way communication, okay, or two-way streaming. It also, HTTP2 has header compression. It reduces the size of the request headers, okay? And also another advantage is, since the protocol buffers, since your API calls to the server and the client, it's in a binary format, the size of it is very small as compared to the regular REST request that you send over network, because your REST API calls are generally in the form of JSON. The body of the request is generally in the form of JSON file, which is a text file, which is very large. So your network communication has to transport more amount of data for the same API request. Whereas the proto file, since it's binary serialized, the size of it is reduced considerably. Now, how do you use the gRPC? Okay, so the workflow is that you define the service, which means you create a .proto file, you define which APIs your client will need, define those, not only define the API calls, define what parameters each invocation will have, okay, the type of the parameters, like the data type of the parameters, and what will be the request format that the client is expecting. Then you can either use Proto-C compiler. It generates the client side and the server side stubs, okay? And then in the targeted programming language, and it handles serialization, deserialization, networking, everything happens behind the scenes, okay? Then you implement the server and you implement the client. So server is generally, it would be, say for example, it could be a user service, which goes and fetches the user data or updates the user data, whatever API you want, okay? Client is the one which, let's say, gathers the information from the UI and sends it to the server. So 4 basic steps. First, you create a .proto file. We will see an example of it. Just stick around, which is nothing but a text file. Then we compile this proto file to generate the stubs, and then we implement the server, and then we implement the client. So what are the key advantages? Superior performance, okay, because the combination of HTTP2 protocol and protobuf, gRPC is super fast, okay, low latency, high throughput, especially advisable for microservices. It is strongly typed APIs. It is not loosely typed like REST, which, as we see when we see the .proto file, wherein you have to define the data type of each parameters and the number of parameters that each request would take or a response will give. Efficient data transfer, because it uses binary serialization, it is much more compact than the JSON, so reducing the network bandwidth. Built-in streaming, it's native support for streaming modes, okay, it's a bi-directional streaming. It is language agnostic, okay, which means the code that, because it's binary, you can have multi-language development, like need not be your server and client need not be written in C# and C# or Java and Java. So your client could be written in some other UI or some programming language. Your server could be written in some other programming language. When to use gRPC? When would you use it? When you're developing microservices, which needs high speed, real-time applications that require bidirectional streaming, low power mobile devices, okay, because of the efficient serialization advantage that you get, multi-language environment. As we mentioned earlier, because of the binary serialization, you are not dependent on one language. So here is a side-by-side comparison. REST uses HTTP 1.1. gRPC is built ground up on HTTP 2. So the data format in the REST, as you might know, it's human readable JSON format. It uses protocol buffers, which we will see an example. Performance is REST less efficient because of the text-based headers and verbose JSON. So the size that needs to be sent, size of the packet that needs to be sent is more than as compared to the binary size. Streaming, built-in support, bidirectional, it's generally server-side streaming. Now, tools to test the REST APIs are widely available, okay, like Postman, okay, which makes it easy for debugging, okay. So that's one advantage that REST has over gRPC. There are many tools which are available for gRPC too, but here, which is that, Bloom RPC is there. You can even use Postman, but Postman doesn't have inbuilt support. For REST, you have the curl. For gRPC, you have gRP curl or gRPC curl. So before we go ahead and look at the Hello World example, three main dependencies that I want to discuss about that we will be using in our Hello World example. One is the gRPC netted shaded library. Why are we using that library? Because it handles the underlying client server implementations to go over HTTP 2. This is the one that has support for the HTTP 2 protocols, TCP sockets, TLS encryption, gRPC stub. So when you compile, it generates the stub classes that is required or that your server and the clients will be using. Okay, so when you compile it, you get your service dot the impl base for server side. You have the blocking stub client for client call, service future stub for any future where you have asynchronous programming style, or your services stub, which is again using for async client, stream observer for streaming responses. Then there is one more which we use as the protobuf. Okay, so protobuf is obviously the heart of it. It's a glue between protocol buffers and the gRPC Java. Okay, so let's see how your proto looks like. So when you define a dot proto file, this is just an example. This is a service like hello service. This will be your outer class, hello service. Now say hello returns hello response. So this is your API method call name, your remote procedure name. This is the request class and this will be the response class. So this method, say hello, will accept the parameter of type hello request class and it will return a response of type hello response. Okay, so hello request and hello response are nothing but classes. When we see the full dot proto file, you will see there. So gRPC protobuf makes it possible for it generates the hello service gRPC. So if you had a user service, it would generate user service gRPC class. It will serialize and deserialize hello request and hello response because they are the parameters that will be passed over the network using protobuf. Okay, so let's see it in action. So here you see I have my full proto file. So you're using the proto3 syntax. This is my Java package. If you see com example gRPC, outer class is hello proto, which will be generated. So method say hello, which see here, hello request and hello response. They are both defined here. And what it is that hello, the request will contain only one parameter called name, and the data type of that parameter would be string. That's why we say it's strongly typed. If you had one more parameter, you would define here. So name, so say age. So the second parameter would be of type int and say age equal to 2, something like that, or integer, I think. So, okay, oh, sorry, it does not have the prototype defined, okay? So you would define the data type, age, I mean the parameter name and its position. So second position is age, okay? So that's how you defined your request. What you're getting is a message response, which is in the type of message. If it was a class, you would say here it would be a class, say user class or some other class that you need. Okay. Server, okay. Simple, you're creating a server, just a gRPC server, nothing much. The main heart is in the gRPC service. Now see here, say hello, which is here, say hello. Okay. So it is implementing say hello. Okay. Don't worry about all this. In IntelliJ, the class path is not set, but we are using Maven for compilation. So here is my POM. Okay. So you're importing all the request responses because it's not generated yet. So you don't see any target here. And then what you do is your service implements just say hello, the parameter name, which is coming from the request. So request.getName. And then you just say hello and pass it. And the client is nothing, just doing connecting to the server, passing the name as Alice and printing the response out. Okay. So the first step what you're going to do is go here. Before this, what you need to do is Maven clean install. Maven, it's already clean, but anyways, install. So this will generate your, if you see here in IntelliJ, it should generate your target. Here it generates the target classes. See here, we have the hello service gRPC. You have the hello proto, that was the outer file name. Okay. It used the dot proto. So basically what it did was generated all these generated files for you. If you see this icon, these are the generated files. Hello proto and hello service gRPC was generated. These three were already there, right? We already had created gRPC client, server, and hello service. Next, let's run the server. So for server, here it is. So what you're doing is I'm using Maven to execute my Java program, running the server, and here it is gRPC server started on port this. And now this is just the client. It's running the gRPC client. So client will establish a connection with the server. And see here, you got a response. Hello, Alice. Okay, because Alice was the name we passed from here. So that is all about gRPC. I will upload this code, simple code, to GitHub, from where you can download it and just take a look at your POM file. The dependencies, gRPC dependencies that we talked about are here. Okay, some plugins that we are using, but all this will be uploaded on GitHub, where you can easily download it and make changes and play around with yourself. All right, that is all for today. Hopefully your understanding of gRPC is a little bit more clear after listening to it. Feel free to put any comments, suggestions, everything welcome. Okay. All right. Thank you all. Thank you for listening. Have a wonderful time.